Right. So good evening, all of you. Yesterday we have discussed regarding few things related to ray optics. Ray optics is actually a very big chapter again, right? We have seen regarding reflection due to plane mirror, due to spherical mirrors, right? We also started a refraction at plane surfaces. We have seen at curved surfaces. We have seen what is real depth, what is apparent depth. We have discussed related to glass slab. We have discussed few three four important points, and apart from that we have also discussed regarding total internal reflection, right, optical fiber case, and what is the area through which an object can view the outside surface, right. So these points we have discussed yesterday, and refraction at spherical surfaces also we have seen. In today's session we will be talking about some important relations for spherical lenses. We will talk about prism, right, and we will focus majorly on optical instruments. So in a matter of 1 hour, I will try to quickly complete the review. In the next 45 minutes, we will do some questions. Tomorrow also we will do questions of ray optics. Sunday completely, I will slightly take some extra time and complete wave optics, guys. And Sunday in the evening, you can write the exam. Because Sunday is a holiday, we can have the session in the morning itself if possible. Please ask your friends to join on time, guys. Okay. So let us quickly move ahead again. So we have talked about the reflection part. We have also talked about refraction part. Let us try to understand refraction using lenses today. Okay. Right. So basic ray diagrams we are already aware, I guess. So what are the basic ray diagrams, guys? Whenever incident ray is passing or parallel to principal axis, after refraction through the lenses, it is going to converge at the focus, or it will appear to diverge from the focus, as you can see in the first case. So for convex lens, it will converge at the focus, and for concave lens, it will be appearing to diverge from the focus. And an incident ray passing through optical center will move undeviated again. In the same manner, if incident ray is passing through principal focus, after refraction it is going to become parallel to principal axis. So these are the three rules majorly that we remember in case of image formation using lenses, guys. Incident ray parallel to principal axis, after refraction converges at focus or appears to diverge from focus. Incident ray passing through optical center will be moving undeviated. Incident ray passing through focus, after refraction it will become parallel to principal axis. So these 2 points we have, again, those are the major points if you know, to find out image formation using lenses. Now just like we have studied important relations for spherical mirrors, in the same manner we have important relations for lenses. Let us try to revise a little bit of mirrors also. So yesterday we have seen mirror formula. What was mirror formula, guys? What was mirror formula in contrast? 1 by v plus 1 by u is equal to 1 by f. Here in case of lenses, it will be 1 by v minus 1 by u will be equal to 1 by f. There also, if you see, guys, magnification was given as height of the image divided by height of the object. Here also it will be given as height of the image divided by height of the object. Also, in case of lenses, magnification is given as v by u. You need to remember these values. However, the derivation parts we cannot see, as I've already discussed yesterday, right? Whereas in case of mirrors, what was it, guys? It was minus v by u. Please tell me what was it in terms of focal length and object distance? For mirrors, I'm writing here. It was f divided by f minus u. And what was it in terms of focal length and image distance? It is same, guys. F minus v divided by f. So these are not including sign convention. And sign convention, so basically we have seen, right? All the measurements should be taken from pole or optical center. And if the measurements are taken above principal axis, they should be taken as positive. Below principal axis, they should be taken as negative. All those measurements opposite to the direction of incident ray should be considered as negative. In the direction of incident ray should be considered as positive. So these are some basic rules which you need to know in case of your lenses, guys. However, as we move ahead, we will talk about few more cases in lenses again, which we have studied yesterday in contrast with the reflecting surfaces. These are your refracting surfaces again. So lenses will basically be part of two spheres, guys, and in between them some material is going to be filled. Mirrors were part of how many spheres? Mirrors were part of how many spheres, guys?
One sphere.
Mirror was part of one sphere only, whereas lenses will be part of two spheres, guys. So if you are placing two spheres, the intersection of two spheres, and the region is filled with certain diffractive index or with certain medium, it will behave as convex lens. And if two spheres are placed side by side, the space between them, if it is filled with a certain medium, then it is going to behave as a concave lens. 1 by v minus 1 by u is 1 by f, lens formula. 1 by v plus 1 by u is 1 by f. Which formula, guys? Mirror formula. Magnification, there also height of image by height of object, here also height of image by height of object. Whereas magnification in terms of lenses will be given as v by u. For mirror it is minus v by u. Right, in terms of focal length and image distance, both f minus v by f, f minus v by f only. However, for focal length and object distance it is different. Focal length, in terms of focal length and object distance, for mirror it is f divided by f minus u, and for lenses it is f divided by f plus u. Is that clear? Now, please also tell me what is focal length in case of mirror, guys? Focal length of mirror, can you please tell? Arey
Radius.
yaar, huh?
Radius of curvature by
It is
2.
r by 2 or not? Right? For which type of rays is it valid or it is applicable? It is applicable for paraxial rays only. What are paraxial
Paraxial
rays?
rays.
Those rays which are very close to the principal axis and parallel to the principal axis. However, what will be focal length for marginal rays? It will be r minus r into 1 minus 1 by 2 cos theta. This will be for marginal rays. What are marginal rays again? Those rays which are parallel to principal axis but away from principal axis. This is in case of what? This is in case of mirrors, guys. Right? Similarly, for lenses, as we move ahead, we will study. But before only, I'm telling it, guys. Focal length of lens will be found out by using a very important formula called as lens maker formula. The lens maker formula, it is used to find out the power of the lens. Power of the lens will be given as reciprocal of focal length of the lens, and the formula will be mu2 by mu1 minus 1 into 1 by r1 minus 1 by r2. We will look into that as we move ahead, guys. So, and in the same manner, if we talk about power of mirror, guys, power of mirror will be negative reciprocal of focal length. Power of mirror will be negative reciprocal of focal length, whereas power of lens will be reciprocal of focal length, which is given as mu2 by mu1 minus 1 into 1 by r1 minus 1 by r2. What is mu2? As I said, lens is made with the help of two spheres. The space between the spheres is filled with a medium. So mu2 is refractive index of the material of the lens. In the same manner, mu1 is refractive index of the surrounding medium. If you look at this diagram, the inner part, whatever material is there, that refractive index will be taken as mu2. Outer part, whatever material is there, the refractive index of it will be considered as mu1, right? And similarly, r1 and r2, these are radius of curvatures, guys. So if you look at this, this is our incident ray. It is incident on this surface first. So this will be our first refracting surface. In the same manner, this will be your second refracting surface. Likewise, for concave lens, this will be our first refracting surface. This will be our second refracting surface. So R1 and R2 are radius of curvatures. In every case, guys, I have not included the sign convention. Right? The formulas are exclusive of sign convention, guys. They are not including sign conventions. We have to include sign conventions while we are substituting the values of focal length or object distance, image distance. We need to include the sign conventions. So focal length of mirror, we know directly it is r by 2, or for marginal rays r into 1 minus 1 by 2 cos theta, which we have seen yesterday. For lenses, focal length will be given by a formula called as lens maker formula. It is this formula, guys. The lens maker formula will give us power of lens. Power of lens will be given as how much, beta? Reciprocal of focal length, mu2 by mu1 minus 1 into 1 by r1 minus 1 by r2. Mu2 is refractive index of the lens. Mu1 is refractive index of the surrounding medium. R1 and R2 are radius of curvatures. Is that clear, all of you? Is that clear, everyone?
Yes, sir.
Yes, sir.
Right. So in till now we have discussed about magnification. That magnification is when object is placed perpendicular to the principal axis. What if object is placed along the principal axis, guys? What if object is placed along the principal axis? If it was placed perpendicular to principal axis, we wrote magnification as height of the image divided by height of the object. Whereas when it is placed along the principal axis, guys, then I am going to write the magnification as length of the image divided by length of the object. So what is a dash b dash? If you look at this, a dash b dash is the length of the image, guys, and AB happens to be length of the object. So lateral magnification or axial magnification, it will be given as ratio of length of the image to the length of the object. However, for concave mirror, guys, we can write the magnification as minus v square by u square. For lens, it can be written as v square by u square, where v happens to be the image distance and u happens to be the object distance. Or in general, we can also write it as minus longitudinal magnification square, guys, and this can be written as anyhow plus longitudinal magnification square. Is that clear, all of you? Here M stands for longitudinal magnification, ML stands for lateral magnification. We will use a term longitudinal magnification when the object is placed perpendicular to the principal axis. When it is placed along the principal axis, I am going to use a term called as lateral magnification. For concave mirror, the lateral magnification will be minus M square times the longitudinal magnification, and for convex lens, it will be M square times, guys. I hope it is clear. Is that point clear, all of you?
Yes, sir.
Yes, sir.
Right. Oh, these two cases are very important because similar kind of question directly can be asked based on these two cases. Very important cases, guys. Right. What they have given here is, if you just kindly look at this, a point object is placed in front of a convex lens, it seems. A convex mirror is placed behind the lens so that final image is coinciding with the object. What they are saying, final image should coincide with the object. So when will final image coincide? Again, it's very important, guys. Right. See, if you look at the ray diagram, if I assume this is the object, it is a real object, guys. Usually for a real object, you have divergent type of rays which are going to originate from the object. For real object, divergent type of rays will originate. For real image, convergent type of rays will, or they are going to terminate at a point, guys. Understand it very. For real object, divergent type of rays will originate. So if incident rays are converging at a point, then it will definitely be a virtual object. In the same manner, real image will be formed if the reflected rays or refracted rays are really meeting, really terminating at a point, converging at a point. If they are diverging, then it will be forming a virtual image, guys. I hope it is clear, all of you. From a real object, divergent type of incident rays. From a virtual object, convergent type of incident rays. For a real image, convergent type of reflected or refracted rays. For a virtual image, divergent type of reflected or refracted rays. I hope it is clear, all of you. So what they are saying is two cases are possible. Sometimes they will ask you what is the distance between the lens and the mirror such that the final image coincides with the object, guys. Yesterday we have seen a case where two concave mirrors, identical concave mirrors were placed at some separation whose focal length was f, and we placed a object midway between the two mirrors. So they have asked us what should be the distance between the mirrors such that the final image coincides with the object. There we took two mirrors, guys. Here they have given us a lens as well as a mirror. So they are asking us what should be the distance between the convex lens as well as the convex mirror. So you should take always pole to optical center, pole to pole, or optical center to optical center distance. Okay, so object is placed somewhere over here. I want the final image to again coincide. So when will final image coincide? Very basic logic. The final image will coincide. See, this is our incident ray. This will be our refracted ray. If the refracted ray falls normally, again you take this point, guys. A point on a sphere will behave as a point on a sphere. What will it behave as? Arey, cheppandi bhai. Hello.
Plane
Pole.
mirror.
A point
Plane
on,
mirror.
it is a plane surface. If it is uh, silvered on one of the side, then it is going to behave as a plane mirror. Yes or no, all of you? right? So now you see, and if I take this point, if the ray is passing through the center of curvature, so this point happens to be what? This point happens to be the center of curvature of the convex mirror, guys. So this is our incident ray. Refracted ray will behave as incident ray for the convex mirror. And how is this ray incident, guys? It is falling normally on the convex mirror. So when it falls normally on the convex mirror, what will happen? It will retrace its path and again come back here only. Okay. Or if not, instead of taking this particular ray diagram formation, we will take one more ray diagram. Let us say this is one of the incident ray, guys. Is this incident ray passing through optical center? Is this incident ray passing through optical center? Yes. So what will happen? Will it move undeviated or not? Yes, it is going to move undeviated. Now you can see this is our incident ray. This will be our refracted ray. The refracted ray will now behave as incident ray for the convex mirror. Okay. Now you see the incident ray. How much angle it is making at pole? Incident ray, is it making any angle at pole, guys? No, it is making 0 degrees. And yesterday we have seen one more law of reflection, again rules for image formation using spherical reflecting surfaces. What will happen to the reflected light? Will it again come back or not? Yes, it is again going to retrace the path, beta. So this is how the image will again be formed at the object itself. So what is the condition here? Very simple logic. If I take convex lens, right, I'll just show it over here, guys. We have taken a convex lens. They're asking us the condition where the final image again coincides with the object. So what we can take? We can take the object somewhere over here. Divergent type of incident rays will come. What is the use of convex lens? It will converge the rays, guys. In reality, if convex lens was not there, the ray would have traveled like this. But because of the presence of convex lens, it is going to get converged. Now this is refracted ray. This light happens to be our incident light. This light happens to be our refracted light. This is refracted light for convex lens. Now it will behave as incident light for which mirror, beta? Convex mirror. And what is the condition for object, for image to again form at the object? Basic condition. Whatever refracted light is there, which is indeed behaving as incident light for convex lens, now that should be converging at center of curvature, or it should be converging at the pole of the convex mirror, guys. I hope it is clear, all of you. Yes or no? So whenever incident ray is passing through center of curvature, will it retrace its path or not? Yes, it is going to retrace its path. In the same manner, you can take one more ray. It is passing through optical center, so it will move undeviated. So this is our incident ray. This is our refracted light. Again, you can see this will be our reflected light. This will also be our reflected light. So again, final image will be forming at point O itself. In this case, they will ask you to find what is the distance between convex lens and convex mirror. So object distance will be given to us. So let us say object distance is given. In the same manner, focal length will also be given, right? So you know focal length, you know object distance. Can you find the image distance, beta? Yes, we can find by using which formula? Lens formula. So we can find image distance from this. So can you find image distance? Indeed, we can find image distance. So this is our image distance. And we also know from here to here is our radius of curvature. So what will our distance between the lens and the mirror be, guys? If you look at the diagram, what will the distance be? Can you please tell? How much will the distance be? It will be V minus R. So they will ask you to find what is the distance between convex lens and convex mirror such that final image is again coinciding with the object. In this case, it is V minus R, guys. I hope you have understood. Is that clear? See,
Yes, sir.
object distance will be given, focal length will be given. So can you find the image distance by using lens formula? Yes, you can find the image distance. But what is the condition here? The refracted light will behave as incident light for convex mirror, and that light should be converging at the center of curvature. Only when it converges at center of curvature, it will retrace its path back and again the image will be formed at the object itself. So you can find image distance from here. Radius of curvature will also be given. So the distance between the lens and the mirror can be found out by using V minus R. Whereas in second case, guys, the refracted light, which will indeed behave as incident light for convex mirror, if it is incident at pole also, again image will be formed at the object itself. So in second case, what will be the distance between the lens and the mirror? It will be exactly equal to the image distance, guys. Clear? So two cases are possible. In first case, the refracted light should be appearing to converge at center of curvature. In second case, the refracted light should be converging at the pole of the convex mirror. Okay, so in first case, distance between the lens and mirror will be V in second case, and in first case it will be V minus R. I hope it is clear, all of you. Yes or no? Vachalog? Hello, am I audible?
Yes, sir.
Right. So as I said, lens maker formula again, right? Lens maker formula can be used for finding out focal length of the lens, any type of lens again, which is given by mu2 by mu1 minus 1 into 1 by r1 minus 1 by r2. So for different types of lens, the formula is given here. I will just explain it for one of the lens so that you can understand it easily for the other lens, guys. So basically, I'll take plano-convex lens. Okay. So we will take a plano-convex lens to make you people understand. I'll take it something in this manner. In reverse manner, I'll take it, guys. Okay. So they're asking us to find out what is the focal length or power of your plano-convex lens. You see, if you take incident light, is this incident light, will it get first refracted by this surface or not? Because it is a curved surface separating two transparent media, guys. You see, this is one surface. To the left of it, we have air. To the right of it, we have mu. So is it an interface separating two transparent media? Yes. So whenever there is an interface separating two transparent media, what will take place? Diffraction will take place, obviously. So here you are going to have your refracted light. Clear, all of you? So incident light will first get refracted by this surface, and this surface will be part of some sphere like this, guys. It will be part of some sphere in this manner, whose center of curvature will be somewhere over here, which is C1. So this is our first refracting surface. Then the refracted light will now undergo refraction using this surface. How do you visualize a plane surface? Plane surface, will it be a very small part of a very large sphere, can I consider? So this plane surface is a certain part of a very large sphere you can take, guys, whose center of curvature is lying somewhere over here, C2. So this is our second refracting surface. All measurements should be taken from optical center. Let us say this is the center of the lens again. So from the center to first center of curvature, is this measurement taken in the direction of incident ray, guys? Is this measurement taken in the direction of incident ray? Yes.
Yes.
So R1 value should be taken as positive.
Positive.
In the same manner, this particular, let us take from optical center towards center of curvature. What will R2 value be? It's a very large radius again. Is it being
Negative.
taken opposite direction of incident ray or not? Yes. So R2 value should be taken as negative. So here R1 you can consider it as plus R. R2 you can take it as minus infinity. I hope you have understood why I have taken minus infinity. Yes or no? Why
Yes,
did we
sir.
take minus infinity? Because plane surface will be part of a very large sphere, guys. Large sphere means almost infinite radius you can consider. Now, if you apply the formula, very basic part again. What is the formula for finding out the focal length? Lens maker formula. And what is
Lens
it
make.
stating? 1 by f value will be
I.
mu2. What is mu2 here? Mu. What is mu1 here? Surrounding medium. I have not written anything. You can take it as air. 1 minus 1 into. What is radius of curvature for first surface? For first surface, I have taken it as plus r. Yes or no, beta? For second surface, what is it? Minus infinity.
Minus 1.
So
Six.
anything divided by infinity would be 0. Right? So what will I get the focal length as? 1 by focal length will be mu minus 1 into 1 by r. Okay. It's very important again. So we can write focal length of the plano convex lens as r divided by mu minus 1, guys. We can write it as r divided by mu minus 1, and power can be written as mu minus 1 divided by r. This is how we generally calculate focal length of any type of lens, whether it may be a plano convex lens or plano concave lens, biconcave lens, biconvex lens, convex meniscus, concave meniscus. I hope you have understood how to calculate focal length of a lens. Understood, everyone?
Yes.
So I'm not discussing all cases. One case I have told. If you want, you can remember the cases, guys. So for plano convex lens, always remember whenever a term convex comes into picture, its focal length will always be positive. And whenever a term concave comes into picture, its focal length will always be negative, guys. So as you can see, for plano convex lens, you will get the focal length as r divided by mu minus 1. For plano concave lens, guys, you will get the focal length as minus r divided by mu minus 1. Okay. Equiconvex lens, if I take, right, for equiconvex lens, the focal length will be half of the plano convex lens, guys. So you will get this as r divided by 2 into mu minus 1. In the same manner, for equiconcave lens, what will I get? Minus r divided by 2 into mu minus 1. Is that clear? Did you understand, everyone? Why it is halved? Why it is halved? I'll tell you in a very short amount of time in case of cutting of lenses or combination of lenses, guys. I hope you have understood it. Lens maker formula, very, very important, right? Many times question has been asked based on lens maker formula in NEET examination. Understood, all of you?
Yes, sir.
Yes, I hope yes. Right. Now let us talk about combination of lenses. Right. Now, what is the meaning of combination of lenses? Again, formulas only remember basically. So here, I am not a person who will tell you to remember formulas, guys. But time being, because of situation is demanding us to do that. So that is the reason I have to tell that. So when we talk about combination of lenses, there can be a case where two lenses may be in contact with each other, or there can be a case where lenses can be at certain separation, guys. So whenever they are in contact with each other, the effective power will be given as sum of individual powers, guys. You can take any type of lens. And what is power of a lens? Is it exactly reciprocal of focal length or not? What we can write, 1 by f effective, you can take it as 1 by f1 plus 1 by f2 plus 1 by f3 plus so on. So if both the lenses are convex, you will have positive focal length. If both the lenses are concave, you are going to have negative focal length. If you have one convex, other concave, one will be positive, other will be negative. Is that clear? Is that clear, all
Yes,
of
sir.
you? Whereas in the second case, where the lenses are placed at some separation, this is valid only for paraxial rays, guys. It is not applicable for parallel rays. It is applicable for paraxial rays. Okay. Marginal rays are also parallel rays only. It is not applicable for marginal rays. It is applicable for paraxial rays. So effective power will be given as P1 plus P2 minus dP1 P2. Effective focal length will be given as 1 by F1 plus 1 by F2 minus d by F1 F2. Is that clear, all of you? Again, combination of lenses also important, guys. Clear? You can view the recording through YouTube channel, guys. I will, however, post the link in the group also. Maybe after the completion of the class, yesterday's class, I'll post it. Today's class, I'll post it tomorrow because the recording will come to me after 2 hours, 3 hours, something like that. So I'll post it in YouTube and I'll share the link in the group, guys. Next thing happens to be cutting off lens, which is also important again. This question came in 2020, I believe, if I'm not wrong. 2021 also we got this question, cutting off lens. Now we have something called as two planes, guys. So if we talk about lens, we know we have two types of lens. One is convex lens, other is convex lens, other is concave lens, right? Exactly, the center will be called as optical center. It has two curvatures, as we have seen. This will be one of the curvature, and this will be the other curvature. The curvatures will be part of some spheres, guys. You can take this is center of one sphere, this is center of the other sphere. There will be an axis passing through the centers of curvature as well as optical center. This axis is called as your principal axis, guys. Okay. Now I know, I hope that you all know what is a plane surface. So there will be a plane surface. There is a plane. You can take this plane. So there is a plane, XZ plane you can take, guys. There is a plane which includes the principal axis. Is this plane including principal axis? Does it contain principal axis, guys? It is a horizontal plane. Principal axis also x-axis. Will horizontal plane contain x-axis? Yes. So there is a plane called as a plane containing principal axis. There is also a plane which is perpendicular to the plane containing principal axis. It will be something like this. Just like when you cut a fruit, guys, right? First you will do horizontal facet, then you will do vertical facet. Yes or no? The horizontal facet is a plane containing principal axis. Vertical facet is a plane perpendicular to the plane containing principal axis. So two cases you have now. What are those two cases? If you cut the lens using a plane containing principal axis, focal length will not change, guys. However, when you cut the lens using a plane perpendicular to principal axis, focal length will get doubled, guys. I hope you have understood. There is a plane containing principal axis and there is a plane perpendicular to principal axis. So if you are cutting the lens using a plane containing principal axis, right, focal length will not change. However, when you are cutting the lens using a plane perpendicular to principal axis or perpendicular to the plane containing principal axis, then focal length will get doubled. So as you can see here, very simple logic. First thing, you have a focal length. How are you cutting it, guys? How are you cutting it? Horizontal plane or vertical plane?
Vertical.
Vertical. What will happen to focal length?
Double.
हो गया, देखो डबल, देख लो, 2f 2f. Yes or no? हो गया डबल. Right now, what you are doing to the same lenses, now you are cutting it using which plane? Horizontal plane. Will
Horizontal.
focal length change? No. You see, this was 2f. So you take any part of it, you will have 2f only. Clear, all of you? Yes or no, everyone?
Yes, sir.
Right. In the same manner, you take this particular lens. It has focal length f. How are you cutting it?
Horizontal.
Horizontal. Will focal length change? No. So this
No.
part and this part both will have same focal length. Now I'm arranging them side by side, guys. So if I'm arranging them side by side, right, both in same direction, then my effective focal length will become f by 2. How will I get this? Is again, it is combination of lenses. So what will I get? 1 by f effective will be 1 by, for this you have f, for the second part also you have f only. So what will this be? 2 by f. Yes or no, all of you? So what will I get the effective focal length as? You will get it as f divided by 2. Is that clear? Is that clear? Whereas if you keep them inverted, one will converge, other will diverge, making the effective power 0. So when power is 0, focal length obviously will become infinite, guys. I hope it is clear, all of you. Understood? Now, now you see this case. You take this lens. How am I cutting it? Using a plane perpendicular to the plane containing principal axis, vertical plane or not. So what will happen to focal length? Gets doubled. So you see, here you have 2f, this also 2f. Now what I am doing is, I am arranging these two parts. So this part and this part, I am arranging close to each other. So in that case, what will I get the effective focal length as? Will I get 1 by 2f plus 1 by 2f? Will this be 2 by 2f? Will it be 1 by f only or not? So will focal length change here, guys? No, it is not going to change. For the combination, it will not change. I hope you understood it. When you are cutting a lens using a vertical plane, I am going to get two parts whose focal length will be doubled. Understood that point? Now, those two parts I will bring and connect with together. I can connect them either in this way or in this way or in this way or in this way. So in any way I may connect them, their effective focal length will still remain f only. Their effective power will still be p only, guys. Clear, all of you? Understood?
Yes.
Yes.
Yes, sir.
Right. I hope you understood that point. And one more very important point, which was also asked in NEET, I think 2019, I guess, guys. Whenever a lens is made up of n number of materials, guys, let us say lens is made up of different materials. How many images will be formed by that lens? They will ask you. So look at this case. How many materials are used to form this lens? Mu1, mu2, mu3. This is again mu2 and mu1 only. How many materials are used, guys, to form this lens?
3.
3. So as many materials are used, those many focal lengths will be there. Those many images will also be formed. It's a very important point again. So whenever it is not only convex lens, guys, it is applicable for concave lens also. Whenever a convex lens or concave lens is made up of different materials, whatever is the number of materials used to make that particular convex lens, same will be the number of focal lengths and same will be the number of images formed by that particular lens, guys. I hope it is clear. Clear, everyone?
Yes.
Then we have silvering of lens, right? 2 points you need to remember. I'll discuss the concept of doing the question while we are solving the problems, guys. Okay. So what is the concept here? Let us see. Whenever you take a convex lens, guys, it can be any type of convex lens. It can be a plano convex lens. It can be a biconvex lens. It can be a equiconvex lens. It can be a convex meniscus. You take any type of convex lens, and if it is silvered, it is going to behave as a concave mirror, guys. And always remember, concave mirror will have negative focal length and positive power. Whereas if you take a concave lens and when you are silvering it, it is going to behave as a convex mirror, guys. So always remember, convex mirror will have positive focal length and negative power. In the same manner, lens, if I take convex lens, we will we will have second focal length also, but from need point of view, it is not required, guys. For convex length, focal length will be positive, power is also positive. Whereas for concave lens, focal length is negative, power is also negative. Clear, all of you? Right? So convex lens silvered, it will behave as a concave mirror, right? And concave lens silvered, it will behave as a convex mirror, right? So how to discuss that, I'll tell you. We use effective power method, guys. One case I'll explain anyhow, right? I'll directly explain one case so that we will not waste time. Now you see, if I take, this is our convex lens, it is silvered on one of the side. Okay, what we are doing is, one incident ray we have taken. This incident ray, will it first get refracted by this surface, guys, by the convex lens? Yes. So this will be our refracted ray. Now the refracted ray will behave as incident ray for which mirror? Which mirror it is going to behave? Whenever outer surface silvered, concave, inner surface silvered, convex. Yes or no? So this is our incident ray. It will first undergo refraction using a lens, and the refracted ray will behave as incident ray for the concave mirror. Now what will concave mirror do? It will reflect. This reflected ray will again get refracted by using a convex lens, guys. So three things will happen here. First, what will happen? First, the incident ray undergoes refraction by using a convex lens. Then it will undergo reflection by using a concave mirror. Then again it will undergo refraction using a convex lens. So whenever silvering of lens questions are there, we are going to make use of effective power method, guys. So let us say for lens power is P1, for this it is P2, for this it is again P1. So what is the effective power here? You will get it as 2P1 plus P2. P1 is power of lens. How can I write power of lens as? 1 by focal length. P2 is power of mirror. How can I write power of mirror as? Minus 1 by F2, guys. Clear, all of you? And how can we write focal length of the mirror? Focal length of the lens using lens maker formula. What will it be, beta? Mu minus 1 into 1 by R1. Suppose if I take it is equiconvex lens. Let us imagine it is equiconvex lens. So what will our value be? Equiconvex lens. What will our value be, guys? 1 by F value. It will be 2 into mu minus 1 divided by r. And focal length will be negative, so you will get it as 2 by r here. So if you take 2 by r common, you will get 2 into mu minus 1 plus 1. So what will this become? How much is it becoming, guys? 2 by r into 2 mu minus 1 will I get or not? This is our effective power. Mu value is generally greater than 1. So effective power is positive. So whenever effective power is positive, guys, the system is going to behave as concave mirror. They will ask you what is the effective or equivalent focal length. So we got the power value now. So how can I write power as, because it is behaving as mirror, can I write it as minus 1 by f effective? So what will I get the focal length as beta? I'll get it as minus r divided by 2 into 2 mu minus 1. This will be the focal length. This is how we solve questions related to silvering of lens, guys. I hope you understood. Yes or no, everyone?
Yes, sir.
So whenever silvering of lens concept is used or question is given, we will use effective power method. First, we will see what is happening to the incident ray. So in the case that I have taken, incident ray will first undergo refraction using a lens. Then it will undergo reflection using a concave mirror. Then it will again undergo refraction using a lens, guys. So overall, the effective power is 2p1 plus p2. If I assume this to be a equiconvex lens, just now we have seen focal length of equiconvex lens is r divided by 2 into mu minus 1. So I can write 1 by f value as 2 into mu minus 1 divided by r. Clear? And focal length of concave mirror, we got it as negative. Usually for paraxial rays only we take, guys, which is minus r by 2. So you'll get this as plus 2 by r. And whenever effective power of the system is positive, guys, the system will behave as concave mirror. And if effective power of the system is negative, the system is going to behave as convex mirror, right? So you'll find the effective power. From there, you can calculate the effective focal length. And majorly, they will ask you to find out what is the effective focal length of the system when one face of a lens is silvered. This is how you will solve the question. I hope it is clear. Clear, all of you?
Yes.
Right. Let us move to the next concept called as prism, guys. Let me give a quick review of this chapter. From next chapter onwards, I'll keep it very crisp, guys. Okay, whatever is essential, that only I'll be discussing. Although ray optics is a very big chapter, so I have to discuss everything in this. So let us focus on prism. Now, in refraction part, we have usually taken one refracting surface, one plane refracting surface, guys. When we talk about prism, we have to take two refracting surfaces, and those two refracting surfaces will be inclined to each other at a certain angle. As you can see in this case, right? Both the surfaces. So as you can see over here, this is one refracting surface. This is another refracting surface. Are they inclined to each other by a certain angle? That angle will be called as angle of prism. By geometry, I will get the deviation produced in the ray as I plus E minus A. A value will be R1 plus R2, and the refractive index, you can apply Snell's law here, guys. Imagine the surrounding medium to have a refractive index 1, and prism is made to be, it is made up of a material whose refractive index is mu. So if I apply Snell's law, I'll get 1 into sin I as mu into sin R1. I will get mu into sin R2 as 1 into sin E. Okay, this is how you will find out refractive index. Now, deviation variation with angle of incidence is very important. Which graph it is following, they will say. It is going to follow a asymmetric graph, guys. Is there any symmetry? You see, if I just take this particular angle, left side and right side, do they have same graphs? Left side and right side, does it have same graph, guys? No. So variation of angle of deviation and angle of incidence will be a asymmetric graph. It will not be a symmetric graph, guys. So deviation in general will be given as I plus E minus A. A value can be given as R1 plus R2. Refractive index value can be given as sin I by sin R1 or sin E by sin R2. Now, at one particular angle of incidence, deviation will be minimum, guys. And as you can see, It is minimum when angle of incidence and angle of emergence are equal. It is minimum when angle of incidence and angle of emergence are equal, and that minimum deviation will be given as 2i minus a or 2e minus a, or I can also write it as 2 into I minus r, or I can write it as 2 into e minus r. And whenever we are talking about minimum deviation, what are the conditions? Angle of incidence is equal to angle of emergence, and automatically R1 and R2 will also be equal, which are going to be equal to A divided by 2. Okay, I have taken that to be as R, guys. Clear, everyone? And one very important formula is refractive index formula, guys. Again, you will get questions based on this also. Refractive index, how to calculate if minimum deviation is given? It will be sine of A plus delta minimum by 2. A is called as angle of prism. Delta minimum is minimum deviation. Clear? So mu value will be given as sine of A plus delta minimum divided by 2 whole divided by sine of A by 2. Is that clear, all of you? Is that clear, everyone?
Yes, sir.
When is minimum deviation possible? Minimum deviation is possible at only one particular angle of incidence, and that at that particular angle of incidence, what will be equal? Angle of incidence and angle of emergence both are going to be equal. In that condition or in that situation, both the angle of refractions will be equal, and they will be equal to half of the angle of prism. Right? The two refracting surfaces, they are inclined to each other by a certain angle. That angle is called as angle of prism. It is also called as refracting angle. Minimum deviation is possible at one particular angle of incidence, that is where I and E are equal. In that situation, R1 and R2 will also be equal. Clear? These are the four formulas that you need to know in case of prism, and majorly questions will be asked based on this only. I hope it is clear, all of you.
Yes, sir.
Next thing, let us focus on. It's a very important case, guys. In case of prism, it is important case. So they are asking us if angle of prism is less than critical angle, it seems, maybe at second phase, right? So you forget about this point. This case, you see, we'll talk about that point later. If you look at this point, I want the refracted ray from the first surface, right, to retrace back. So in case it is clearly mentioned, one face is silvered, I want the incident ray to retrace its path back from second phase. So first of all, you can take, so I'll just draw the diagram separately again. So you have taken a prism, guys. One of the face of the prism is silvered. So that face is going to behave as what? Plane surface is there, silvered. It will behave as
Mirror.
how? It is going to behave as a plane mirror, guys. So they are saying what should be the angle of incidence, or what should be the refractive index, such that incident ray will retrace its path. So when will it retrace? It is, this is our point of incidence. So you can consider this will be the normal. So you can consider this to be angle of incidence. So how is incident ray traveling? It is traveling from rarer to denser or not? Yes. So in reality, if prism was not there, it would have traveled like this. But because of the presence of prism, it will bend towards the normal. So this is our refracted light. I want this refracted light to retrace its path. So when will it retrace its path, beta? It is going to retrace its path when the refracted light will fall normally on this face, guys. So if it is falling normally, this, you know, it is angle of prism again. This is your R value. If this is 90, how much will this total value be? Will this be 90 minus R or not, guys? Yes, it is. Sorry, you can write it as 90 minus A. Is it 90 minus A or not? Yes. So what will R value be here? One R only we have, which is A. And here R value will become 0 because it is along the normal. Understood, all of you? Basic conditions only will be asked in ray optics. They are asking us what should be the refractive index or what should be the angle of prism. They will ask you guys. Angle of incidence may be given and refracting index may be given. So they are asking us what should be the refractive index or what should be angle of prism such that when one of the face of the prism is silvered, incident ray will retrace its path. So this is our actual incident ray. This is our incident refracted ray. This is refracted ray for first interface, guys. This refracted ray will behave as incident ray for the second interface. So when will incident ray retrace its path? If it is falling normally. So refracted light from the first interface should fall normally on the second face such that the ray will retrace its path. So in that condition, I can write 90 minus A plus R will be again equal to 90 degrees only. So R value will be equal to A, or you can take this value as R1. So R1 value you are going to get it as A, guys. And we already know R1 plus R2 is A because R1 is equal to A. What will I get R2 value as? 0. So now you can apply Snell's law. So I can write 1 into sine I will be equal to mu into sine R1. So what will mu value be? It is sine I divided by sine R1. And what is sine R1 we got, guys? R1 we got it as sine A. Clear all of you? So directly you will be asked this question. Angle of incidence may be given and prism angle may be given. They will ask you this condition. For incident ray to retrace its path back, what should be the refractive index of the prism? What should it be? Sin I divided by sin A. Clear all of you? Is that clear, everyone?
Yes, sir.
Right. Now we have something called as dispersion. Dispersion, combination of prism and optical instruments. Maybe in 15 minutes I'll try to wind this up, guys, and we'll move on to question solving. Right. We got refractive index of the prism as sine of A plus delta minimum divided by 2 whole divided by sine of A by 2. Is this clear, all of you? Whereas if I take thin prism is very small prism, guys, very small angle. So for thin prisms, what is the meaning of thin prism? A value will be less than or equal to 5 degrees. You can take up to 10 degrees also. Up to what you can take? You can take up to 10 degrees as well. So thin prisms are those prisms whose refracting angle is very small. And for small angles, we know sin theta can be represented as tan theta. Sin theta can be represented as tan theta, which can directly be written as theta also again. So what will I get here? Mu value will become, this is for thin prisms, guys, A plus delta minimum whole divided by 2 whole divided by A by 2. So I can write mu A value will be A plus delta minimum. So delta minimum value I'll get it as mu minus 1 into A. This is our deviation in case of your thin prisms, guys. So deviation, as you can see, is directly proportional to what, beta? Deviation is directly proportional to refractive index. Yesterday we have seen refractive index is inversely proportional to wavelength. Whichever has a less wavelength will have more refractive index, will have more deviation. Whichever has more wavelength will have less refractive index and less deviation. Is this point clear? This is applicable for which prisms? For which
In
prism?
prism.
For thin prism. What is the meaning of thin prisms, guys? Refracting angle should be less than or equal to 5 degrees. You can take it up to 10 degrees also. Is that fine? We have some terms. So as you can see, as I've just now told you, that deviation is directly proportional to refractive index. Refractive index is inversely proportional to wavelength. So that is the reason I'll get, as wavelength of violet light is less than red light, refractive index of violet will be more and deviation will be more, guys. Here also they have given one mistake. So deviation in violet light will be more compared to deviation in red light, guys. So that difference in their deviation is only called as angular dispersion. So delta V minus delta R will be your angular dispersion. I can write delta V as mu V minus 1 into A. I can write delta R as mu R minus 1 into A. Mu V and mu R are refractive indices of violet and red light, guys. Okay, so angular dispersion will be difference between deviation in violet light and deviation in red light, guys, which is also given as mu v minus mu r into a. We also have something called as mean deviation. Mean deviation will be approximately equal to deviation in yellow light. It will be approximately equal to deviation in yellow light. And we also have here mu will be mean refractive index, guys. That mean refractive index will be given as arithmetic mean of refractive indices of violet and red light, which is again approximately taken as refractive index of yellow light again. The ratio of angular dispersion to mean deviation will be called as our dispersive power, given by theta by delta, which can be taken as mu v minus mu r divided by mu minus 1, or it's not necessary again. You can write theta by delta only directly. So mu v minus mu r divided by mu minus 1, or you can write it as delta v minus delta r divided by delta. This delta is approximately taken as deviation in yellow color light, guys. So four formulas are important in dispersion. Basically, dispersion is splitting up of white light into seven different colors. We basically call it as Vibgyor colors, guys. So refractive index will be directly proportional to deviation, right? And refractive index is inversely proportional to wavelength. So that is the reason we will say deviation and wavelength are inversely related with each other. Whichever has less wavelength will have more deviation. So deviation produced in violet light will be more than deviation produced in red light, right? And whatever is the difference between their deviations is called as angular dispersion, right? In the same manner, the mean deviation we have, which is approximately equal to deviation in yellow light. We also have mean refractive index, which is also equal to refractive index of yellow light, guys. And there is one more term called as dispersive power, which is the ratio of angular dispersion to mean deviation. These four formulas in dispersion you should know. And from this we will talk about combination of prisms again. Right. So when we consider combination of prisms, there are two cases possible. Two prisms will be given, guys, in such a way that you are going to have dispersion and no deviation. In the same manner, you will have deviation and no dispersion. So as you can see, whenever combination of prisms are given, the net dispersion will be given by theta. The net dispersion will be algebraic sum of individual dispersions. Net deviation will also be algebraic sum of individual deviations, guys. Okay. So for now, two cases are going to arise. One in which dispersion is there, other in which deviation is there. So first case is dispersion without deviation. So deviation is not there here. So what we can write? Net deviation should be 0. So delta 1 plus delta 2 will be 0. Here you can write delta 1 value will be mu 1 minus 1 into A, or mu minus 1 into A you can write, which is first prism, guys. Delta 2 can be written as mu dash minus 1 into A dash. Theta 1 can be written as mu V minus mu R into A, which is angular dispersion in first prism, and theta 2 can be written as mu v dash minus mu r dash into a dash. Whenever we are taking combination of prisms, net dispersion is sum of individual dispersions, net deviation is sum of individual deviations. Two cases will arise. Deviation should be there, dispersion should not be there. Dispersion should be there, deviation should not be there. So when there is no deviation, net deviation will be 0. So I will get this formula, guys. They'll ask you to find the ratio of A by A dash. They will ask you, which I can write it as mu dash minus 1 divided by mu minus 1. Minus sign you will get. Minus sign indicates that they are inverted prisms, guys. And for dispersion to not be there, deviation without dispersion, net dispersion should be 0, guys. And in that case, the ratio of A by A dash, you will get it as mu V dash minus mu R dash divided by mu V minus mu R. These two formulas are very important. This is the formula for dispersion, no deviation. This is the formula for deviation, no dispersion, guys. Clear? Clear, all of you? Combination of prisms and dispersion case.
Yes, sir.
Please remember the formulas directly. While we are solving problems, we can learn something more extra. But as of now, please go and remember the formulas, guys. We have something called as achromatic combination. So it is that particular combination which is free from chromatic aberration. Now, if we talk about chromatic aberration, guys, let us take a white light. As we all know, white light is combination of 7 different colors. Yes or no? So here I am showing it as okay, I'll take it as white light only. So let us imagine we have convex lens. What is the meaning of chromatic aberration? I'm telling you guys. We know white light is combination of 7 different colors. When it is incident on convex lens, if it is suffering from chromatic aberration, guys, the near focus violet light will get more deviated or not. So violet light, I'll just show it with blue color here. So near focus violet light will get more deviated and red light will get less deviated, guys. So it is that particular phenomena in which light is different colors come to focus at different points on the principal axis. So you see, violet light is coming to, or it is getting converged at near focus. Red light is getting converged at far focus. So that particular situation where different colors come to focus at different points on the principal axis, all are not going to come to focus at one point. They're not going to come to a single focal point, guys, right? The colors will be reaching the principal axis at different focuses. The near focus will be violet in color, the far focus will be red in color. Why the near focus is violet in color? Because violet undergoes more deviation and red will undergo less deviation. If I want to remove this phenomena, I am going to make use of a combination called as achromatic combination. That combination free from chromatic aberration. What is chromatic aberration? It is that particular phenomena wherein which different colors come to focus at different points on the principal axis. So if I want to remove this phenomena, I will use a combination called as achromatic combination. That combination free from aberration is called as achromatic combination. Two cases are available where we can use two lenses which are placed in contact with each other, or two lenses kept at some separation, guys. So what is the condition for achromatism? When they are placed in contact with each other, omega 1 by f1 plus omega 2 by f2 will be equal to 0, right? Omega 1 and omega 2, they are dispersive powers. Just now we have seen dispersive power is ratio of dispersion to deviation. Here omega is what? Dispersive power. It is given as theta divided by delta. Second case, what is the condition for achromatism? If both are kept at some separation, the distance between the lenses should be equal to omega 1 f2 plus omega 2 f1 divided by omega 1 plus omega 2. Is that clear, all of you? These two conditions you remember. If they are in contact with each other, omega 1 by f1 plus omega 2 by f2 should be 0. Why did we get 0? Because there is no separation. And if you look at this, we got d value. Omega 1 f2 plus omega 2 f1 divided by omega 1 plus omega 2 will be distance between the two lenses. These are the two combinations through which we can remove the chromatic aberration. If they are placed in contact, omega 1 by f1 plus omega 2 by f2 0. If they are placed at some separation, then that separation should be omega 1 f2 plus omega 2 f1 divided by omega 1 plus omega 2. These two conditions you should remember in achromatic combination. We have last thing, which is optical instrument. Just give me a minute of time. I'll just drink some water, guys. I hope you are able to understand, all of you. Yes, no? Am I audible, everyone?
Yes, sir.
Yes, sir.
अब मोहम्मद जाकिर कौन है भाई? फिर से
Sir Sabahat.
Sabahat. Yesterday only I have told you, please log in with your name. Hemant is there. Rahman Abid, okay. Sadhya is there. Sania Mehreen is there. Siri Chandana. Siri Chandana, you are from VMC, right? श्रीशांत है, वैष्णव है. मारिया प्लीज जरा, हाँ, लॉग इन विथ योर नेम. Amatu Noor also. Both Meghana Reddys have logged in with their names. Malia Muskan, Mehreen Fatima, Krishnaveni, Aishwarya, Hafsa, Habiba, Rakshana, Srinidh has joined, Aksa has joined. Okay. There are few people who are missing. 3, 4 people are missing, I guess. Right. Till here, any problem, all of you? Till here, any problem, everyone? Yes, no?
No, sir.
No, sir.
Is the board visible? Is it visible?
Yes, sir.
Right. So I am not going in detail about optical instruments, right? So I'll just tell you two cases. Remember the formulas in those. Anyhow, while we discuss questions, I'll discuss in brief about the optical instruments, guys. Okay. So three major optical instruments we will have. One is your simple microscope, which is magnifying glass. Other one is compound microscope, which you usually might have seen in your laboratories, guys. And the other one is telescope. That also maybe you might have seen in your schools again. So there are two cases which we usually study in optical instruments. So whenever you view an object, either the object can be placed far from your eyes or the object can be placed near to your eyes, guys. So if the object is placed far from your eyes, will your eyes be relaxed? Will they feel any strain? No. So that situation is called as your relaxed eye condition. Whereas when the object is brought near, will your eyes feel strained or not? So this will be called as strained eye condition or object placed at near point. Object placed at far point, relaxed eye condition. Object placed at near point, strained eye condition. Okay. And when object is placed at far point, the final image will be formed at infinity, guys. Very important points again. Final image is formed at infinity. When the object is placed at near point, the final image will be formed at least distance of distinct vision. For a normal human eye, it happens to be 25 centimeters. This is also called as near point. Far point for a normal human eye happens to be infinity, guys. Far point for a normal human eye happens to be infinity. So when we talk about simple microscope, it will use only one convex lens. Magnification will generally be given as d by u. Very general formula again. D is least distance of distinct vision. U will be object distance. For relaxed eye condition, you see object distance will be equal to focal length. For strained eye condition, see, strained eye condition means it is, are you bringing the object closer or not? Relaxed eye, object distance is equal to focal length. When you are bringing the object closer, will object distance become less than focal length? Yes, obviously. So in strained eye condition, you can remember the object distance will be less than focal length. So magnifying power in first case, relaxed eye case, it will be given as d by f, and in strained eye condition, it will be given as 1 plus d by f. Okay. So the ray diagrams are given clearly. It is same as that of your convex lens only, which you may are already aware. So simple microscope will use one lens only, one convex lens, guys. Magnification for simple microscope will be given as d by u. Two cases we will study, one relaxed eye, other strained eye. In case of relaxed eye, final image will be formed at infinity. In case of strained eye, final image will be formed at least distance of distinct vision. Right? So in case of relaxed eye, object distance will be equal to focal length. So automatically, by convention again, for strained eye, object distance will become less than focal length. The magnification for simple microscope in relaxed eye condition d by f, in strained eye condition 1 plus d by f. Please tell me, where is magnification more, in which condition? Strained or relaxed?
Strain.
Strained eye. They will ask you what is maximum magnification. So please remember, maximum magnification will be anyhow 1 plus d by f only, which takes place in strained eye condition. When you move on to next optical instruments, compound microscope as well as astronomical telescope, they will use two lenses. One will be called as objective lens, other will be called as eyepiece lens, guys. జస్ట్ సెకండ్. హర్షిత్ గారు, ఏంది ఇంత లేట్ వచ్చిర్రు? ఓ హర్షిత్, right. So when we talk about compound microscope and astronomical telescope, we are going to have two lenses. One will be objective lens, other will be eyepiece lens, guys. Now, one very interesting fact in case of compound and astronomical telescope, how many lenses are there in simple microscope? One lens only. Whatever is the function of the lens used in simple microscope, the same will be the function of eyepiece used in both compound microscope as well as astronomical telescope. Understood, all of you guys? Whatever is the function of the lens used in simple microscope, same will be the function of eyepiece lens used in compound microscope as well as astronomical telescope. So whatever formulae we have written for simple microscope, I can use these formulas for eyepiece in case of compound as well as astronomical telescope. Is that clear? Maximum magnification, strained eye condition. In strained eye condition, final image will be formed at least distance of distinct vision. Right? Minimum magnification in relaxed eye condition. In relaxed eye condition, image will be formed at infinity. Whatever is the function of a convex lens used in simple microscope, same will be the function of eyepiece lens used in compound microscope and astronomical telescope. Is that clear? Is that clear?
Yes, sir.
So as you can see, in compound microscope, we will have two lenses. The distance between the lenses will be called as length of the tube. It is given as L, guys. Okay. Now, basic thing again, two lenses it is using. So the magnification will be given as M naught into ME. So what is magnification of objective lens? Because it is a convex lens, it will be given as V by U. Here it is including sign convention, but I'm writing is without sign convention. What is magnification of eyepiece? Does eyepiece have same function as that of simple microscope or not? So what will it be? D divided by UE. Okay. Now two cases again. Two cases. What are those cases? What are those cases? One will be relaxed eye. Second will be strained eye. Maximum magnification in which condition? Strained eye condition. Now please tell. For simple microscope in relaxed eye, what was object distance? Was it equal to focal length or not? Here, object distance of eyepiece will be equal to focal length of eyepiece because eyepiece will have same function as the lens used in simple microscope. So what will I get the magnification as? I will get it as V naught by U naught directly D divided by FE. What will I get it in strained eye condition? देखो बेटा, I'll write same thing. V naught by U naught, but in place of D by FE, what will I write बेटा? 1 plus D by FE. समझ गया? Clear? Yes or no? I hope it is
Yes,
clear.
sir.
In relaxed eye condition, the length of the tube will be V naught plus FE. In strained eye condition, what is object distance? Will it be less than focal length or not? And length of the tube, here you will get it as V naught plus UE. UE is object distance from eyepiece lens, guys. Or I can also write this as V naught plus FE into D divided by FE plus D. Okay. These four formulas you need to remember again. Whatever is the function of simple microscope, same will be the function of eyepiece used in compound microscope as well as telescope. So there in relaxed eye, object distance was equal to focal length. Here in relaxed eye, object distance from eyepiece will be equal to focal length of eyepiece. There in strained eye, object distance was less than focal length. Here in strained eye, object distance from eyepiece will be less than focal length of eyepiece. Clear all of you? Clear everyone? Length
Yes,
of
sir.
the tube is nothing but distance between the objective lens and eyepiece lens, guys. Clear? Understood or not? I'm not drawing the ray diagrams here. Okay, I have already written the formulas. Now, what is the use of telescope? Can you please tell? Use of telescope. It is used to view distant objects, guys. So whenever I am using telescope, I will be able to see the object closer. It will shift nearer to us, guys. Okay. Normal adjustment is also called as relaxed eye condition, which I forgot to tell. So whenever they say normal adjustment, it will be relaxed eye condition. What is the difference between telescope and microscope? One major difference. You see, in case of microscope, objective lens is smaller. So what will f naught value be here, guys? Focal length of objective will be less than focal length of eyepiece in case of microscope. Whereas in case of telescope, objective lens is larger, guys, as you can see. So what we can write here, focal length of objective will be more than focal length of eyepiece. Again, two formulas. One is relaxed eye, other is strained eye. In relaxed eye condition, magnification will be f naught by fe. Length will be f naught plus fe. Okay. So relaxed eye condition, here it is, if it is not visible properly, guys, it is f naught plus fe. In strained eye condition, you see in all the previous cases, I wrote 1 plus d by f. But in telescope, I will write 1 plus f by d, guys. So I'll get the value as f naught by fe into 1 plus f by d, fe by d. This is the magnification in strained eye. And here in case of the length of the tube will basically be given as f naught plus ue again. Again, strained eye, what is object distance from eyepiece? Less than focal length of eyepiece. In relaxed eye, object distance from eyepiece will be equal to focal length from eyepiece, guys. Clear, all of you? Understood, everyone? Again, I can write ue value as fe into d divided by fe plus d. So these are the formulas that you should be aware in optical instruments. Totally, how many formulas, guys? 6 formulas. Apart from astronomical telescope, compound microscope, and simple microscope, we have two more instruments. One will be your terrestrial telescope. The other will be your Galilean telescope, guys. However, they are not that much necessary. Terrestrial telescope will be same as your astronomical telescope only, but instead of using two lenses, it will use three lenses, guys. And that will be, one will be your objective lens, second will be eyepiece lens, third will be another convex lens. You can consider it as a artificial lens also, guys. So length of the tube will be basically given as f naught plus fe plus 4f. What is f here? It is the focal length of the third lens that we are using. Magnification anyhow will be given as f naught by fe only, guys. In Galilean telescope, till now you have seen in all the microscope or telescope that we have taken, all were convex lenses only. Whereas in Galilean telescope, one objective lens will be convex lens, eyepiece lens will be concave lens. So here length of the tube will be given as f naught minus fe, guys. Okay, magnification anyhow is f naught by fe only. Clear, all of you? So these formulae you should be aware, and apart from that, you should also know the resolving power, guys. Basically, for telescope, the resolving power will be given as d by 1.22 lambda. For microscope, it is 2 mu sine theta divided by 1.22 lambda, and resolving power will always be reciprocal of limit of resolution. Okay, resolving power is always reciprocal of limit of resolution, guys. And limit of resolution for human eye will be 1 minute. Okay, majorly again, this is very important because twice we have got a question in resolving power. Direct question, guys. Resolving power inversely proportional to wavelength. Based on that, you got a question in 2019 Odisha paper you got, and once you got in 2018, I guess, somewhere 2017, 2018. Okay. So this is the review of your ray optics chapter. I'll explain anyhow these terms while we are doing some questions, guys. Any doubt in whatever concepts we have discussed today?
So,
Sir, पूछिए.
sir, when we were finding the the case in which when we are placing a convex lens along with a mirror, concave mirror, sorry, convex mirror, so we are considering that the image will be formed at the object position itself.
Again, object only. Yes,
Yes, sir. So, but
this is the case.
we are considering the image distance to be the distance from the convex lens to from the concave convex mirror. I see.
We are considering the image distance.
To be equal to the to be from the convex lens to the center of curvature of the mirror. Why so?
This one. Why
Yes,
so
sir.
means? Why so means
What
the
is formula?
image formed. Listen, the image formed by the convex lens should be at center of curvature, and the image formed by the convex lens will behave as object for convex mirror. Okay, so I am writing lens formula for convex lens. So where should the image be formed by the convex lens? It should be formed at the center of curvature of convex lens, convex mirror, such that the final image will coincide at the object. That is the reason I have taken V value as D plus R, as you can see here. Understood? When the refracted rays fall normally on the convex mirror, then only they will retrace back. When will they fall normally? If they are appearing to converge at center of curvature. So this will be the image formed for the object by the convex lens. Okay.
Sir, but still the final image is being formed at the object, sir. So why are we not
Yes,
considering it
it is
from?
formed at object only. No. It is formed at object when I bring into effect convex mirror. But if I am not considering convex mirror, where is the image formed by the lens?
At the center of
Here,
curvature?
no? That is the reason I am writing the lens formula. I have nowhere used convex mirror case here.
Yes, sir. Please.
So the image formed by the convex lens should be at center of curvature. Final image is formed at object, but final image is considering the effect of both lens and mirror. I am not talking about mirror now. I have taken only mirror to show you that the refracted ray should fall normally or it should fall at the pole. Clear?
Yes, sir. Clear.
Any other doubt, all of you? We can discuss around 10 questions like that, I guess, today, and the rest of the questions we'll discuss tomorrow. Sunday we can have maybe a little bit extra session because it's holiday for everyone. Holiday na bhai, everyone. ये मत बोलो sir, no holidays for us, sir. I I also don't have holidays then if that is the case. Right. And by the way, again from tomorrow I have to commute between Warangal and Karimnagar. Okay, so that is another problem. Nonetheless, right? So no problem. We will continue with the sessions by hook in any case. Any doubts in whatever has been discussed? Although the review of ray optics took a long time because it's a big chapter, but I will try to make it very much precise from next chapter onwards with an intention that major focus will be on problems. Clear all of you? Hello? Any doubts, guys? Yes, no? Okay, let us quickly solve some questions, guys. Is the board visible? Is the board visible?
Yes, sir.
Right. Are the questions visible?
Yes, sir.
Right. First question you see, we have something called as a person can see clearly objects only when they lie between 25 centimeters and 200 centimeters. Right. First thing which you need to know in this, normal eye, if I take, what is near point? If I place the object at 25 centimeters, then only I'll be able to see it clearly. And what is far point? Far point is infinity. Clear? Now, in the question, you see, what is near point given? I can see when it is placed between 25 centimeters and 200 centimeters. Means nearsightedness is there, guys. But I am not able to see far objects. So he is suffering from which disease? myopia. Clear? It is also called as nearsightedness. You can see the near objects. So near point will be 25 centimeters only, but far point will become less than 25 centimeters. Is that clear, all of you? And how will myopia be corrected? By using which lens? By using concave lens. Concave lens will have which focal length? Negative focal length. Which power? Negative power. So automatically from this, can I cancel out plus 0.5D minus 0.5D? Yes or no? Arey yaar. Did you understand?
Yes,
If
sir.
you are a normal human being, if you have a normal eye, the near point should be 25, far point should be infinity. Okay, but in the question, if you see, the person is able to see the objects when it is lying between 25 and 200 centimeters. So near point is not changing. What is happening to far point? It is less than infinity. So it is a myopic eye, guys. And myopic eye will be corrected by using concave lens. Concave lens will have negative power, guys. Yes or no? So what I should do? I should increase this far point to infinity. Yes or no? So if I use the lens formula, 1 by v minus 1 by u should be equal to what, beta? 1 by f. Right? So what would be the condition in this case? What is the condition in this situation? Where should the final image be formed? It should be formed at infinity, guys. Right? So if I take a eye lens again in general, this is our eye lens. Yes or no? How am I going to correct? In front of the eye lens, I am going to place a concave lens or not, guys? I'm going to place a concave lens like this. Okay. So we are going to have a common principal axis, something in this manner. We are going to have a common principal axis like this. Now, where is the far point? Far point is not at infinity for this eye. Far point is somewhere over here. Right? Now, I should ensure that these rays are coming from infinity. So when will they appear to come from infinity, guys? Means they should, the rays should become parallel again. Right? So I'm just removing this part completely. So we got to know our final image should be formed at infinity. Right? Object distance, you can take it as 200 centimeters, guys. Right? So we will directly get 1 by final image should be formed at infinity minus 200 will be equal to 1 by f, implies 1 by f value will be minus 1 by 200. So which turns around centimeters is given. So I can write minus 1 by 2 meter inverse. So power will be minus 0.5 meter inverse, which is also given as minus 0.5 diopters, guys. Clear, all of you? Normal human eye, near point 25 centimeters, far point infinity. Right? Far point is less than infinity means it is myopic eye. Near point is more than 25 centimeters, then it will be hypermetropic eye, guys. Myopic eye is corrected by using concave lens. Hypermetropic eye will be corrected by using which lens? Convex lens. Clear, all of you? Understood?
Yes, sir.
They are asking us to increase the distance of distinct vision to infinity. Then I should use which lens? So correcting lens should be a concave lens, which will have negative power. So our answer should be minus 0.5 diopters. Clear? Yes or no?
Yes, sir.
I hope it is clear. Now, next question, if you see. An air bubble in a glass slab, when viewed from one face, appears at 9 centimeters and appears at 5 centimeters from the other side. What are they are saying? What is the thickness of this slab? Again, you might have come across such questions. Let us take a certain slab, guys. This is a certain slab. In reality, where is the air bubble? Let us say it is present somewhere over here. In reality, it is here. So this distance from one face, it happens to be x1. From the other face, it happens to be x2. So what will thickness of the slab be in reality? It is x1 plus x2 or not? Right? So this is some denser medium. The surrounding medium happens to be air only. Where is the observer? Arey, where is the observer, bhai? Is it in rarer medium? Where is the object? The air bubble is in denser medium. So whenever object is in denser medium, when observed from rarer medium, will it be at a certain height above its actual presence or not? It will appear to be somewhere over here. And here also you take, it will appear to be somewhere over here. Clear all of you? So what will this distance be? It is again based on real depth and apparent depth. What is this distance? Is it x1 by mu? And what is this distance? It is x2 divided by mu. So what is given? X1 by mu from one side they are saying 9 centimeters. X2 by mu from other side they are saying 5 centimeters. So what will x1 value be? 9 mu. What will x2 value be? 5 mu. What is the total thickness, guys? Is it 14 mu or not? Which you can write it as 14 into mu value is given as 1.5. So I'll get it as near about how many centimeters? 21 centimeters. Is that clear? So the thickness of the slab should be 21 centimeters. Understood? Yes or no?
Yes, sir.
Right? It is based on real depth and apparent depth concept. I hope you have understood, all of you.
Yes.
Right. Let us move to the next question. Microscope they have asked, guys, now. Compound microscope is consisting of two convex lenses, it seems. Microscope. Which lens should be larger? Again, microscope will use two lenses, guys. One will be objective lens, other will be eyepiece lens. Which lens will be larger?
Eyepiece.
Eyepiece will be larger. So what is focal length of the objective here? 3 centimeters. And what is focal length of the eyepiece, beta? 5 centimeters. What is separation between them given? Separation between the uh, lenses is nothing but length of the tube or not? They are asking where you should place an object left to the objective lens so that final image is formed at 25 centimeters. Final image is formed at 25 centimeters, it seems. Which eye? Which eye, beta?
Relaxed.
Strained. No, it is strained eye condition. Final image formed at infinity is relaxed eye. Final image formed at least distance of distinct vision is strained eye condition. So they are asking f naught is given, fe is given, length is given. Okay. Now, firstly, in strained eye condition, 2 points I have given. Length of the tube in strained eye condition. Don't worry about the review, guys. I will try to write it down some important points and share it with you so that you can review. Length of the tube in strained eye condition will be given as f naught plus ue. Okay. Do you know length of the tube? Yes. How much is it? 25. Focal length of objective lens? 3 plus ue. So what will ue value be, guys? It is 22 centimeters. Okay. We got ue value. Yes or no? Sorry, it is v naught plus ue, not f naught plus ue. So what they have given, compound microscope, I'll just draw the diagram here for understanding purpose. So objective lens will be smaller, guys. Eyepiece lens will be larger. Please understand this question. Majority of optical instruments you will have clarity. And you are going to have eyepiece lens, something like this. Okay. So I have taken an object. I have placed it in front of an objective lens. This is your objective lens. Right? This is your eyepiece lens. Okay. Object is placed in front of the objective. Incident ray parallel to principal axis. After refraction, converges at the focus. Incident ray passing through optical center will move undeviated, as you all know. Yes or no? Incident ray passing through focus moves undeviated. It is moving something in this manner, let us say. And incident ray parallel to principal axis will converge at the focus. So this will be focus of your objective lens. And do we have real intersection? Yes, we have real intersection. So this will be the image formed by the objective lens. image formed by the objective lens will behave as eyepiece for the will behave as object for the eyepiece, guys. So what is given to us? I don't know the object distance. They are asking us to find u naught value. From here to here, we can say it is v naught. And what will this be? This is image formed by objective lens. It will behave as object for eyepiece. This is your optical center. This is another optical center. Okay. And where is the final image formed, guys? They are saying that final image is again formed at least distance of distinct vision. So you please look at this incident ray, refracted ray, refracted ray. These refracted rays will behave as incident rays for the eyepiece, and these are our final refracted rays. How are these final rays, guys? Are they moving apart from each other? Because they are moving apart from each other, can they really meet? No, they cannot really meet. They will tend to meet when produced backwards. They will tend to meet when produced backwards. So here is our final image formation. And what is given? They have mentioned that it is formed at least distance of distinct vision. So from here to here, it is your capital D value. Understood? Whatever is the image formed by the objective lens will behave as object for eyepiece lens. What is length of the tube? Distance between the two lenses will be given as length of the tube. Can you please tell me what will length of the tube be in this case? See, if it is relaxed eye, the image will be formed at focus of eyepiece. If it is strained eye, image will be formed within the focus, means between focus and optical center, guys. So what is the length of the tube you see from here to here? V naught. From here to here, UE. And D also is given. Now what I'll do? Lens formula, basic lens formula. For eyepiece, do I know object distance? No, I don't know. Do I know image distance? Yes, I know. Do I know focal length? Yes, I know. So what I'll do, I'll apply lens formula. 1 by V minus 1 by U will be equal to 1 by F. What is image distance? All measurements should be taken from optical center. From optical center to the image. Is it being measured opposite to direction of incident rays? Yes. So I'll write 1 divided by minus D. What is object distance again? Minus UE only. Should be equal to 1 by focal length anyhow will be positive only, guys. So what we can write? Minus 1 by D plus 1 by UE will be equal to 1 by FE. Okay. So what will I get from this, guys? 1 by UE value will be 1 by FE plus 1 by D. FE value we know it is 5 centimeters. D value we know it is 25 centimeters. So I'll get this as 6 divided by 25. So UE value will get it as 25 by 6 centimeters, guys. Now you know length of the tube. What is length of the tube? V naught plus UE. Length we know it is 25. V naught plus UE. And UE also we got to know how much is UE value? We got it as 25 by 6. So what will V naught value be, beta? 25 minus 25 by 6, which is 25 into 5 by 6 you will get, I guess. Am I right? 150 minus, so will this be 125 by 6 or not? Yes. See, I have applied lens formula for eyepiece. I have applied length of the tube formula. They're asking us U naught value. In order to find U naught value, do I know V naught? Yes. Do I know F naught? Yes. So can't we calculate? Now I'll apply for objective lens, guys. So if I'm applying for objective lens formula, I'll apply for objective lens. What are we going to get? 1 by V naught minus 1 by U naught will be equal to 1 by F naught. So V naught is anyhow positive value, which is 125 by 6 minus 1 by, I'm not taking sign convention here. This is 1 by 3 again. What I'll get the value as 6 by 125 minus 1 by 3 will be equal to 1 by U naught, implies 1 by U naught value will be 18 minus 25 कितना है भाई? 18 minus 125. Is it minus 107? Yes or no?
Yes, sir.
It, right, divided by, will this be 375 or not? So u naught value will be minus 375 divided by 107. So near about 35, something like that you will be getting. Let us just check it, guys. Oh, no option at all. Did we do any mistake? Just see. 3.5 you will get, I guess. Clear? Option is there. 375, 100, 107 we have, no? So near about 3.5 centimeters should be your answer, guys. Clear, all of you? This is how we calculate. Very important question again. And what is minus sign indicating here? Minus sign is indicating the sign convention. So where should the object be placed from the objective lens? It has to be placed at a distance 3.5 centimeters such that final image will be formed at least distance of distinct vision. Understood? Understood, everyone? Did you understand how to solve questions related to instrument?
Yes, sir.
Yes, sir.
So what we have done in strained eye condition, please remember, in strained eye condition, length of the tube will be V naught plus Fe. Okay. And what is the condition here? Whatever is the image formed by the objective lens, that will behave as object for eyepiece lens. So I have applied lens formula for eyepiece, I have applied length of the tube formula, and I have applied the lens formula for objective lens in order to come to the answer. Understood, everyone? I hope it is clear. Let us do one more very simple question and we can end the session for today. A mirror is producing magnified image, it seems, erect image, it seems. Magnified image. Can can plane mirror produce a magnified image?
No.
No. Height of the image should be equal to height of the object. So plane mirror is gone. Right? If plane mirror is gone, automatically fourth option gone. Yes. So automatically what will the answer be? Concave. Understood, everyone?
Yes, sir.
Convex will produce an erect image, but it will produce a diminished image, guys. It cannot produce a magnified image. Convex mirror cannot produce a magnified image. It will produce a erect image. It can produce real image. It can produce virtual image, but it will produce a diminished image. Concave mirror has the ability to produce a virtual image, erect image, and magnified one. Only concave can do that. Okay. Is that clear? Right. So the other questions we will discuss tomorrow. Hopefully, tomorrow session will be a very important session. Maybe I will extend the session to maybe 2 hours, guys, 7:45 to 9:45, something like that, and we will discuss maximum questions from from ray optics and optical instruments. Okay. And similarly, Sunday session also will be a 2 hour session in which I will give the review of wave optics and discuss questions. Sunday evening, you will have test on ray optics and wave optics. Any doubts in today's session, all of you?
No, sir.
My humble request for you all is to please go through all the questions, right? Previous year questions, as I have said before, right? Please go through previous year questions. And I have tried to discuss maximum points in ray optics, but because we were doing it at little pace, maybe you may not remember all the formulae, guys, but I would request you to please revise for 15-20 minutes also. Whole formulas you please revise, that would be very important. Okay. Please solve previous year questions of ray optics and solve and just remember the formulas of ray optics, guys. That will fetch you 12 marks in NEET exam. 12 marks is very, again, very much important as far as NEET is concerned. Okay. Clear, all of you?
So,
जी सर बताइए.
so could you just show that